Let's start. Good morning, good afternoon, and good evening. Thank you everyone for taking our time today for this webinar. My name is Zishan. I take care of digital marketing at Utthunga. We welcome everyone to this webinar, Journey from OPC Classic to OPC UA using Tunler. In this webinar, we will help you understand how to replace OPC Classic with OPC UA communication in your planned network in a planned manner. Before we get started, I would like to introduce Utthunga. Next slide. We are a product engineering and industrial solutions company. For over 14 years, we have partnered closely with industrial OEMs to build products and solutions from concept all the way through the life cycle of the product. Our engineers have added digital layers to mechanical, non-digital field devices, built configuration and calibration software, highly sophisticated data integration, visualization, and analytics solution, provided consultation and services on industrial security and quality engineering. We offer services in application development, embedded services, IIoT, and verification and validation. Our services are targeted to OEMs and in industries in process, factory, and power domains. Next slide. Utthunga is present in 4 locations. We have offices in USA, Germany, Japan, and headquarters in India, which is Bengaluru. We are an ISO 9001 and 27001 certified company with 600 plus engineering professionals striving to deliver world-class services and solutions to our customers. Next slide. These are the few industrial consortiums we closely work with on connectivity and protocols. Industrial connectivity is the foundation for Industry 4.0, and that's how we started as a company about 14 years ago. That is, connecting field devices and assets to hardware and software systems up in the value chain. Our association with these consortiums is rooted in our commitment to help our customers build interoperable industrial systems. Next slide. With that, I would like to introduce the speaker for today. Praveen Kumar Singh leads Utthunga's OPC-based product engineering and OPC product portfolio. He has more than 20 years of experience in implementing OPC solutions for ONG and other industry verticals. His keen understanding of clients' perspectives help him deliver multiple OPC solutions and products for several use cases. Praveen holds 3 patents on OPC technology and is also certified OPC trainer, certified cybersecurity professional, and Honeywell certified system architect. Just quick housekeeping points before we get started. The duration of the webinar is 60 minutes. We will utilize the last 10 minutes for Q&A segment. Please send in your questions using the Q&A icon on your left-hand side of your screen. The presentation slides and the link of the webinar recording will be emailed to you post-webinar. We request you to click on the full screen icon on your top right-hand side of your screen to get a good view of the slides. Before I hand it over to Praveen, let's have a poll for 30 seconds. I request the attendees to please select your options. Describe your current OPC Classic setup. We have got a majority response have come in the same network. So without further delay, I would like to hand it over to Mr. Praveen, our speaker for today.
Hello, everyone. So let's go to the next slide. Okay, so today we are going to talk about one of the most interesting and relevant problem in the industry, which is how do you actually move from the OPC Classic to OPC UA? And why is that? If you look at the current industry scenario, most of the companies in the industry is using OPC Classic, and OPC Classic was a very big hit. I mean, it has been used successfully in almost all the verticals, and it's being used widely across different networks. But the problem with OPC Classic was it was built maybe 20 years ago. I think 1997 they started, and at that time it was built on the only technology available, which was the best technology in the market at that time, which was ComDecom. And ComDecom, though, is a very good technology, it is outdated. It was built 20 years ago, and it did not really consider many points that are required today or that has to be adhered today. And what are those points? So if you look at the drawbacks, I mean, ComDecom was designed even before internet was there, even before cybersecurity field was there. So it did not consider many things while designing, and some of them are like multiple ports. ComDecom favors speed over security, so it uses dynamic ports from the network to have a faster speed, and that ports are not even defined. It will just keep picking random ports from the network to make different calls. You also need DCOM permissions. I mean, whenever a OPC server needs to talk to OPC client, you need to open a lot of permissions. And these permissions allow not only one specific client to connect to that OPC server, it can be used by other clients also to get it connected. And this becomes a problem. How it is a problem? Now, before I go to the next slide, I can see, it's good to see such a good turnaround. I see a lot of people in attendees, and I'm pretty sure most of you must be having a lot of industry experience. Okay, so let's understand from our point of view what has changed in last 15, 16 years. If you look at it, suppose you had a vendor coming to you somewhere in the time of 2000 to 2003 and giving you a product. What are the questions you will be asking to that vendor to gauge the product? The typical questions are, how fast is the product? What is the performance of the product? What is the response time it is giving me? How can it scale up? Right? How can it reduce the cost? But you would not ask security. It was all about performance. But today, in 2021, when a product comes from the vendor and you as an end customer start gauging it, how do you start? You start from security questions. The questions would be how this product, when installed or implemented, will change my security configurations, how it will impact my firewalls, how it will impact my network security infrastructure, how it will impact my other products. Because today we are more security aware, and there's a reason behind it. If you look at it, the market, okay, there have been attacks on the plants, cyber attacks on the plants, and that causes a lot of damage. Okay, so this is a real and practical threat, and it has to be solved. And ComDecom was not designed for this kind of network or this kind of market. Now, the problems. Even ComDecom has issues. There are some other issues also, which system integrators or end customers which are facing for their classic products. And what are those issues? If you look at it, suppose you have a OPC Classic server, which is running just perfectly fine, but you need a small change. You just want to upgrade one feature, want to get some tags added, or some want to have one command added. You just cannot get it now because all the major vendors today, if you take some of the names like starting from Matricon OPC to Kepware to Softing, all of them have moved on from working on OPC Classic product to OPC UA products. Have you seen any OPC Classic product getting released in the market in last 1 or 2 years? There are none. Nobody works on it anymore. And now, if you want to get changes to your product, which you had purchased maybe 10 years back from one of these vendors, and you go back and say, hey, I want to get these changes done. either they would not decline it, or you need to get a custom work done. It's like buying extended support from Microsoft. They would still support you, but it costs a lot. And it is just not viable, because as you go on, you cannot keep paying money for each and every feature that you are looking for. But the fact is, if you want to have working product in the plant, there will be new feature that you would need, and these changes would keep coming. That's the first problem. Second problem is, and this is a very good problem. The second one, right? Whenever there is a OS patch upgrade comes, okay, anybody who's handling OPC Classic, ask them, okay, they lose sleep over it, because they know the moment a patch comes, the moment a new server upgrade comes, all the OPC Classic server will stop working. And why is that? Because Microsoft cautiously is trying to stop COM-DCOM at the application layer, because it opens a lot of security loopholes. So first there was a security access permission, then they added another layer of it, which is called limits, then they added some other policies, because they just don't want to have any open security loopholes, and COM-DCOM was one of the big ones there. So they are trying to patch everywhere. In fact, if you look at some of the early attacks or viruses which were there, they were built in terms of COM activist control. And I'm pretty sure that you must have all of used Internet Explorer some time back, or Chrome. And when you click on some components, you start getting red blue lines there, or there'll be highlights saying, do you really want to download this, because this component looks really dangerous. That component actually is a COM activist control which gets downloaded in your machine. And because it's a COM control, it can directly start accessing the OS rather than having a managed environment like Java product, Java component, or a .NET component. Okay, so Microsoft is trying to patch security loopholes, but whenever he does that patching, that results in breaking of current OPC communications. Your OPC servers or classic clients will stop working. And then you have to again go back, you have to reconfigure things. They may then release some paper to say, okay, open this hole, bypass this security to go forward. And any smart customer, any intelligent customer knows that this is just not the way forward. We cannot keep doing this every now. So neither we can keep paying money for every small features, nor we can keep changing the settings every upgrade. So what is the way? The way forward is, you have to slowly start phasing out your OPC Classic products in a proper manner, and slowly start putting OPC UA. And that's how we go next. So let's talk about this in the next slide. But when you want to do that, so now we are pretty clear with this, that yeah, every client today knows that they do want to go from the classic client to the UA products, or UA clients, or classic server to UA servers. But how do we do it? Because all these products are running in live plant. And anybody who's coming from industry knows that in a live plant, a downtime of maybe 2 hours, 3 hours, or day can cost you thousands of dollars, hundreds of thousands of dollars, depending on whether it is running. Because you may lose the data from a well which is getting oil for you. You may not know what is going on some remote wells, and sometimes it could be hundreds of wells, or tens of wells, because the server was pulling data from all those wells, right? So you need to be very, very cautious when you do this upgradation. And that's why you need to plan the upgrade in a phase-wise manner. Now that is first part. Now suppose even if you plan it, how do you know that once you do the upgrade, what would happen? Will it work? Will there be a communication failure? And if there are failures, how much time is going to take to repair that failures? You have no idea. And that puts a lot of trouble. That gives a lot of sleepless night to the people who are going to do it. Because with this question not answers, you do not know how much downtime I'm looking at it, how much data I'm going to lose, right? And you cannot get this. I mean, anybody who's coming from plant environment, or plant industry, will know, if you don't have this data, you will just not get the approval to go ahead and do the rollout, because you are just walking into an unknown, and you can't just do that in such a highly critical machinery. And to answer the first three questions, what management suggests? Management says, why don't you first do a small POC? Get a small POC done. You have a proof of concept. Show me a proof of concept where you can show me that, yeah, hey, this is a way I can go from OPC Classic to OPC UA without losing a data and without having any unknowns. And then once we are convinced, yeah, you can do the complete rollout. So now we'll look into all these questions and how do we answer these questions, okay, in next slides. So now the tools required for this are OPC UA Proxy, OPC UA Wrapper, and OPC UA Tunneler, which is nothing but OPC UA Proxy and OPC UA Wrapper coming together. Okay, now we'll understand each of them one by one. Now let's talk about these products one by one. Now, OPC UA Proxy is a product which sits between an OPC Classic client and OPC UA server. You can see it here. This is a product, okay, and converts UA data to a DA data to make it available to OPC Classic client. Okay, so when the Classic, suppose there's a Classic client which is there, and you have a UA server, and you want to make them connect, what you need is a OPC UA Proxy. So what it does, it will expose Classic server interfaces to this Classic client, and it will expose this data once it comes to inside in a UA way to the UA server. So it actually, in nutshell, converts a COM-DCOM communication, because Classic client only understands COM-DCOM. That we know that. And internally, once the data comes here, it gets converted to a TCP/IP communication. Okay. And what is OPC UA Wrapper? Now, OPC UA Wrapper does the opposite of it. Suppose you have OPC UA client and you want to convert the data from OPC UA client, which is running on TCP/IP, and connect to a OPC Classic server. Then what you need is a wrapper. A wrapper is nothing but a component which has a UA server and Classic client built. So it will give an OPC UA interface to an OPC UA client here. Okay, with this, it will give you endpoints. And once the OPC UA client starts making the queries, internally, he will convert all those queries to a Classic client, to a COM-DCOM communication, and pass it to the OPC Classic server. Okay, and now comes the most interesting part. When you put both of them together, you get what is called an OPC UA tunneler. Okay, see, typically, I know in our poll, we saw that most of you are using a OPC Classic setup within a same network or within the same domain, but there are many places where OPC client and servers are used across domains, and there is a DMZ zone sitting in between, or there is a firewall zone sitting in between. So before I go ahead, let me just explain DMZ a bit. DMZ stands for demilitarized zone. Okay, this concept has been taken from military word, where they block an area and they say nobody can access this area. And if you want to really look at the real world example, imagine any border, any border between two countries. And there is a border between two countries, and there'll be some space in between that two countries where, if they want to go from one side to another side, you have to open the gates on both the sides. And that's how people can walk from that border to another border. But the area between that two border, which is left, will be a DMZ. Okay, which is a very secure area, and nobody really can walk in there other than the authorized personals when people, the security people allow it. So a DMZ is a similar concept in the software world or network security work, where what happens is the IT guys will differentiate two network by adding two firewalls at their end. Okay, so imagine there is a OD domain, okay, office domain, which is connected to internet, where everybody can access internet. But the problem of everybody accessing the internet is that internet can also access them, isn't it? And a super hacker or a good hacker can always come through the same channels that you are using it, and get inside your computers. And once he gets inside one computer, he can actually go to any computer within that domain. And office domain getting hacked is still okay because there are only office PCs and this. But if he gets into a PCD domain where all the field devices are running, which are controlling this huge machinery, okay, that's going to be a chaos, because he can literally stop a machinery, stop a BIM pump from pulling the data, oil data. He can raise the temperature to have issues, and can collapse the whole wet field by having a simple hack. So plant guys are super concerned about the plant security, especially the PCD security, and that's why they never ever expose the PCD domain to the internet world at all. But still, there are components sitting in PCD domain and OD domain that need a communication, and to achieve that, so the first thing is to separate them. What they do is they put two firewalls, which is one is at the end of the OD domain and one is at the at the start of the PCD domain. And that's how nothing from the OD can directly go to PCD. And even at the PCD level, they have another firewall, and that's how called DMZ. Now coming back to our case, the advantage, see, OPC, if you look at OPC UA, okay, OPC UA, okay, so when Foundation was building OPC UA, they learned from their mistakes, or not really the mistake, I would say, whatever was done in the Classic, or whatever ComDecom was doing it, and try to improvise that to make it relevant for the new world, to current plant scenarios. So ComDecom had this issue. So they came back, they switched from ComDecom and they went for the TCP/IP. So in OPC UA, you have a TCP/IP communication, which uses OPC UA binary encoding, which is super efficient, can really work really fast, and works on a single port. It only uses a single port to do all the communication. And that can be used here effectively. So what is a tunneler? You have a client here sitting in an office domain. Okay. This client wanted to access something which is sitting in the PC domain, which is a Classic server here. And from here, what you do is you connect to a OPC UA proxy. Okay, when you connect to an OPC UA proxy, the OPC Classic client, which was pulling a data, is still seeing a Classic server. For him, there's no change. He just have to configure to a different prog ID, and he gets the same point that he was pulling earlier. But internally, what proxy would do, he would take this ComDecom data, communication, convert it to UA client or UA communication. But this is where the trick comes. OPC UA communication requires a single port TCP/IP communication across firewalls. If you just raise a request in a plant to your IT guy saying, hey, I need this port to be open across both the firewall, because this is the port I'm going to use on OPC UA communication, they would simply approve your request, and they will be super happy to solve that and send the data from proxy to wrapper. Okay, so you get the approval. And on the other side, you have a UA wrapper, and you configure this proxy to talk to this wrapper, and your problem is solved. So this client actually thinks he's talking to a ComDecom OPC UA proxy. This guy thinks that he's getting a call from ComDecom, but actually internally at the DMZ level, it is effectively converted from ComDecom to TCP/IP using a single port, and the problem gets sorted out. And now we will see, we are going to talk more about this in our case study that we are going to discuss, but this was just the context for that. So now let's get to the case study that we are going to look at it. So guys, you can keep sending your questions. If you have any questions, we'll take the question answer at the end. But if you have, you can start writing in the QA sections. And when we come at the end of the session, we'll take each of them one by one based on the time availability. Now, let's take a case study. We have this case study, okay, where we have 3 OPC clients running in OD domain, and we have 3 OPC server running in PC domain. Every client is connected to other server, and these clients are separated across DMZ, because it's very common, I mean, you go and talk to a plant guys. You may have Yokogawa client, you may have Honeywell client, you may have Rockwell client, and you may have same servers. You may have some Yokogawa servers, Honeywell server, and they may be pulling data from each other. It's a very, very common scenario. And this is how the setup looks like. When you have a OPC client running across a DMZ zone, okay, IT guys are not happy. Okay, they are super scared about this because ComDecom never tells you what port is going to use. Rather than that, it gives you a dynamic port range. And the worst part is, or the scary part is, that port range also changes with the OS releases. Okay, I personally have seen that OS port range change from some number to some number because some of them started getting used by some other applications. Okay, and they have to open all that ports, and you just cannot control when a call is made from this client, which takes ComDecom and goes to DMZ, which port it will take and how it will come here. Okay, so they have no choice. The IT guys have no choice but to open all of the ports which ComDecom demands. Okay, and that's why we have so many lines open here. I mean, this could be hundreds of ports, or we just for a simplicity and for to keep the diagram clear, we have shown only 30, 40 lines, but there could be hundreds of ports open here actually. And this is a real scary situation for IT guys, because even though they have firewalls, there are so many ports open, they don't know what could get hacked, or which of these ports can be accessed by some hacker if he gets access to and get into the other side. Okay, and they want a solution. So this problem that we are discussing is not only a problem from end customer or the vendor, it is also a problem of IT security and IT guys. Okay, I personally have been at many plant sites, okay, and one of the guys who have really troubled me or who have raised this concern big time are the IT guys, because they can't control what they are giving to the end customer, and because of this, other people can also get affected. Now, let's see how do you solve this problem. So now what we will try to do is, we will first try to clean up the DMZ network. Okay, this is the DMZ network, and the first step to go for all of this to UA is first try to let's sort it out this DMZ network and clean it up. Okay, and here we can use the tunneler that we just talked about. Now what I'm showing you is just a implementation of tunneler that I was discussing some time back. Okay, I'll just wait for here a minute so that you guys can understand the diagram very well. Spend some time, a second on the diagram, then I'll start explaining it. So now, if you look at it, what is happening? All these OPC clients who are sitting on the OD domain, they connect to an OPC UA proxy. So what we have done is, or what the person who's providing a solution does is, he installs OPC UA proxy on one side. He installs OPC server or the wrapper on the other side, and he let all these clients and server connect to it. So all the clients now, rather than connecting to the end server, start connecting to this proxy. Okay, he creates a dummy copy of the servers here in the configuration, and he gives them that copies, and all of them connects to that proxy, and that proxy uses a single point of communication, which is OPC TCP, OPC binary, to go from OD domain to PC domain, and here it talks to a UA wrapper. And once it connects here, the proxy knows, I mean, when he's sending a data, the data is coming in such a way that they know what request is from which client and where it should be routed. But they all are using the same port. And that way, the DMZ guys are very happy. Their problem is sorted out. Rather than having a plethora of ports open, a wide range of port open here, now they have to open a single port. And they are very happy and thankful to the guy who do this. Okay, and this is where the journey also starts, because now you know that UA communication is working fine at the network layer. There are no issues. Port opening is fine. It can work across DMZs. Okay, at least this level proof of concept is done. Now, let's go for the... Okay, before I go ahead, okay, now, suppose you have only this much problem. Okay, what I'm talking about is, see, as I told you earlier in the previous slide, is OPC UA Proxy is a one product in itself. OPC UA Wrapper is another product in itself. Okay, they are two separate products. And when they come together, the combination, when they start working with each other, the combination of them is called OPC UA tunneler. Okay, but they themselves are complete product. So suppose you are only looking for the DMZ cleanup. Okay, you don't really have other, I mean, your problem statement is not going for upgrade and all that. You just want to clean up the DMZ firewall because of IT compliance or because of some other security policies which are getting rolled out in a plant, and you just can't run any more firewall ports open because of security policies. Your problem is sorted out here. You can stop at this level. So whatever we are showing you is complete journey going from classic to server, but at each step, if you think your problem statement was this, you can just stop here. So this itself are solution to many problems, and there are many case studies only on this part, but we wanted to take you through the entire journey, so we will complete the other slides as well, or other problem statements as well. Now let's go on to the next step. Now what we'll do is, in the next step, we will try to remove the clients. Okay, how do you do that? So let's look at it here. Now what we are trying to do is, we are trying to replace the classic client with the OPC UA client. Okay, so this is possible. See, in a plant, no, you can't just suddenly replace everything via the new stuff, right? You need to do everything phase by phase. So even if you have purchased new software, you had old classic software, and you have purchased the new OPC UA softwares, you just cannot stop everything and put new thing. You have to go in a phase-wise manner because of the problem that we discussed earlier. And what is the best way to do that? The best way to do that is first have a redundant pair getting set up. Okay, and when the redundant pair starts working and start pulling data with the same capacity, with the same performance that as the old one was doing it, okay, after some testing, maybe a week or 2 weeks of testing, depending on your security policies, depending on your company policies, you can shut down the old ones and go for the new setup. And that's what we are doing here. So in our case, the customer has purchased 3 UA clients. Okay, so what we are doing is, we let them have these UA clients installed on the OD domain. Now look at how they are connecting. These UA clients are connecting directly to the wrapper. Because as we understood in couple of slides back, a UA wrapper is nothing but a UA server classic client. So this UA wrapper can not only connect to the proxy, but can connect to all the UA clients. It can connect to actually any UA client. Okay, so now all these UA clients can directly connect to the UA server. And even though we are showing 3 lines here because we want to show 3 parallel connection, look at it on this side. They all are using the same endpoint which OPC UA server exposes. Okay, so they all are using the same port, the single port which was open, but because there are 3 parallel connection coming in and connecting to the one same port, we are showing 3 lines. But at the DMZ level, the same port is open. There are no extra ports getting opened here. And we keep the old OPC clients also running at the same time. Okay, because with this, now when these both are running, now at this point in time, your QA team will come in picture, or your integrators will come in picture. They will start collecting the data, and they will start wiring the data and start looking at all the parameters and see if the new setup is anyway performing below par with the old setup or doing better than the new setup. Is it putting extra load on the network? Are there any extra side effects? When they install this, did anything else change for other products? All that checks happens, and this activity takes around, you can say, maybe 2 weeks time. And then once all this is done, okay, they would take out the UA client. They would take out the OPC clients, and they will go to UA clients, and that's what happens in the next slide. So now what has happened here? Okay, now you see they have taken down the OPC Classic clients. OPC Classic clients are completely gone, deprecating, and only UA clients are there. Now OD domain has been cleaned up. In the OD domain, the COM-DCOM is gone, because see, COM-DCOM doesn't only, as I said, it's very performant. for the end customer, it's a delight to use it, but at the network layer, it puts a lot of load because it just keeps opening ports. So now this, I mean, IT guys who are managing the OD domain are very happy because all that COM/DCOM is gone. It is only UA clients which are coming. They are coming on single TCP/IP port. Okay, and here they are still on the DMZ level. They are still using single port, but because they all are making a separate connection, parallel connection, we are showing 3 parallel lines. But at the firewall level, they are using single port. So now you have completed one part of the story. Okay, UA clients are done. You have UA clients running on the OD side, okay, and getting the data. And this data can be wired to the same system which was earlier used, which was getting a data from the classic. Okay. Now we will go to the next step. And what is the next step? The next step is to take the classic server out and replace them with a UA server. Okay, now let's go to the next step. Now, this is the next step where this happens. Now, if you look at it here, what is happening exactly here is, so these are 2 different steps. We'll talk one by one of these both the steps. Here, what is happening is, in the PCD domain, similar to what we did with a UA client, we are doing exactly the same job in the PCD side. First, we have a wrapper. So this was originally there. We already had the wrapper. We are putting 3 UA servers, which are acting same as what OPC servers were doing. So they are pulling the data from same devices. They are pulling the data from same sources, but they are giving this data in a UA server way. Okay, and this UA clients, okay, they being a UA client, they can connect to the wrapper as well. They can connect to the servers. They can create 2 sessions and they can start pulling the same set of data, and then you start doing the same set of measurements. You start finding it out whether you are getting the same performance that you are looking for. You are getting the same scalability that you are looking for. Is it persistent? Are you having any connection drops? And does the machine have any issues? I mean, is OPC server stable? Are there crashes and all that? And you do this activity for next couple of weeks. Once you do this activity for next couple of weeks and you know that, hey, looks like my UA servers are running just fine, okay, you can take out the OPC Classic servers. And that becomes the last step. In the last step, what happens is, now we come from here to here. Now, if you look at the last step here, now we have taken care of this. The wrapper is gone and these UA servers are running. Now, if you look at both the sides, PCD domain is clean. All the COM/DCOM is gone out and OD domains are clean. But here, one more change happens. Now, because there are 3 different UA servers, there are 3 different UA clients, you may have to open some more ports. You may have to open one port for this, because this UA server is using his own endpoint running on a separate TCP/IP port. This UA server will use another point. This will use another point, and this all clients will connect to them based on whatever their condition is. So in the DMZ, you may have to open 3 ports. But with this setup also, security guys are pretty happy, because when you talk to security guys, where they had to open a plethora of ranges, plethora of OPC UA, COM/DCOM points, ports, they are just reduced to 3 or 4 ports. Okay, and each of this, now before I go ahead, I'll just go back a second here. So now from here, now I'll start addressing the customer problem in the customer language. Okay, see, customer doesn't really talk about COM/DCOM and network security. They have a problem and they come to us. Here, the customer problem that you are trying to solve was, I have a OPC UA Classic server running on one side of a domain. I have a OPC Classic client running on the other side of a domain. how do I connect both of them across firewall without opening COM-DCOM ports or without compromising my firewall, without opening all those permissions? If this is a problem statement that you are getting, your answer is use tunneler. Use both the set of server, proxy and wrapper together, put it across firewall and configure UA TCP port, and you are done. Now, here, let's see what is the end customer problem. If the end customer, okay, comes and says, hey, I have a UA clients, I have a UA client and I want to connect to an OPC server. Or you are saying that you got the UA clients, you want to convert the DA data or the classic data to connect to a UA data, then what do I need? You can say, hey, in that case, you can simply use wrapper. Okay, a wrapper is enough. You don't need proxy and all that, because here you already had UA clients. You already had UA clients. You have classic server. And if you want to do that, you just have to install OPC UA server. And you can still take care of all the DMZ issues because they are running across this and they are going to work on single port. Similarly, if you have a reverse of that, okay, which we saw in the next one here, before we go ahead, right? I mean, if you wanted to solve the here, if you want to solve a problem where a UA client, sorry, 1 minute, let me go back. Yeah, you had a problem where you wanted to connect OPC clients to UA servers. If you want to connect OPC clients to UA servers, what do? In case you want to connect to OPC client to UA servers, you only use OPC UA Proxy. Because what proxy is capable of doing? Proxy is capable of converting or collecting data from UA servers, which is this. Behind this, what is there doesn't matter, you know. So if you actually have UA servers here and you have a client here, okay, you can simply use a proxy and he will do the job for you. So what we are addressing are three different problems. If you want to simply clean up the firewall, DMZ, what you are supposed to do? If you have classic clients and UA servers, what we are supposed to do? And if you have UA clients and classic servers, then what we are supposed to do, right? So this is how you have all the answers. Finally, you get this setup done. And if you now let's go back and look at let's go back and look at the points that you are trying to answer or we are trying to see. So this were our dilemmas that we faced while doing the upgradation. How do I plan to upgrade from OPC Classic to OPC Communication in a phased and well-planned manner? If you look at the case study that we just walked through, we were planned and we went in a phase-wise manner, isn't it? Right? We first tried to clean up the DMZ. Then we tried to remove the OPC Classic client, and that also we did in a redundant manner. We actually added the UA clients and we tested the data for some time. And only when we found that the UA clients are doing the job, then we took care of taking out the classic client. And with this, we did the same thing with the classic servers. We first added UA servers. We tested them parallelly in a redundant manner. And only when we found that they both are doing the same job, they are getting us the same performance parameter that are expected, we took out the classic servers. And now what is the third point was minimum downtime. You can see in the case study that if everything goes as per the plan, you will have no downtime at all, right? Because when you are taking out the clients, classic clients or classic servers, there is already a parallel link running in the UA and there is no data loss practically for field guys or other operational guys. Because if you look at the plant, if you look at the process engineers or the field engineers, okay, they don't care about this setup. They want their well data on their dashboard all the time. And if that doesn't come, they are not happy about it, whatever way you do it. Now, the last point is valid proof of concept. Now, if you look at the way we walked through the case study, okay, we started the proof of concept only, right? When we got a tunneler working across DMZ, the first proof of concept worked that, hey, UA is working in the DMZ zone. I can open the firewall ports and it can use the firewall port properly and it is working. And then when we went for the UA upgradation, when we put the client, when we put the server, we were always doing phase-wise manner. So everywhere, before we actually went for the final rollout, we looked for some testing. We took 2 weeks time and tested the parameters before we went ahead. So all these 3 questions were answered. So now, yeah. I think now we have covered almost everything in this case study, and whatever I'm showing you, okay, this was done. I mean, we have actually, I personally have supervised this whole setup, and this is how we did it for one of our clients. Okay, we can't disclose the client name for obvious reasons, but this was done at a client place, and this has been running successfully. And this whole exercise there, I think it took about 6 months of time based on whatever they had it, and they had their own compliance and process regulations guidelines, but it depends. And in their case, they wanted this whole setup to be moved, but we have answered queries where they just wanted DMZ to be cleaned up, they just wanted wrapper to be there because they had only one part of it. Okay, so this is how you move from OPC UA Classic client to, or sorry, OPC Classic client server, the whole Classic setup to UA setup in a planned and phase-wise manner. Okay, so this is where I finish my presentations. Now we go for questions. I think we have around 10 minutes now. We'll take the questions for maybe 5-6 minutes. You can start typing your questions in the Q&A box, and I'll try to answer them. Okay, so I have a question. OPC UA Proxy and wrapper are hard devices, or it is only software? So they are softwares. Whatever we are showing you are plain softwares. Okay, they are software components, just like they are built in a .NET or C++. There are many software available in the market. But at the end of the day, they have installer. You install just like you install any other software, and you just configure them. Okay, okay, so Matricon OPC have 2 tunnelers. They have the OPC Classic tunneler, and this is one of the question. Okay, so this question I have answered many times. So Matricon has a Classic tunneler, and they have UA tunneler also. In the case of Classic tunneler, whatever I've shown you conceptually, same thing happens. You have one component running on the client side, one you have on the server side, but the mechanism which is used in between is the TCP/IP communication only, but it is not UA. They are using a proprietary protocol because Matricon OPC Classic tunneler was built even before UA was there in the market. Okay, they also have UA tunneler, and if you look at their UA tunneler and Utthunga UA tunneler, they should be similar, but now we have to look at the performance criteria, what are the performance number we are getting it, and based on your need and based on what performance you get it from there, and the support, because when you are using all these products, support is very important, right? What kind of support you get it, you have to go for one of them. Okay, so there's one more question I'm getting. Does performance degrade with the use of tunneler? Okay, so there's a question that when you put obviously when you're putting a tunneler in between a Classic COM and Classic server, there's one additional hop getting added, right? The data goes from Classic to wrapper, gets converted back to the server. So even though hops are there in our testing, whenever we have tested it, we have not seen really a huge difference. Okay, all the product that we are talking about, we were using I can tell you the update rate was around 1 second. The client customer requirement that they wanted to get the data from at the 1 second update rate, I'll say for a point load of around 50,000 points for one server, and we did not really see any difference in the performance. Okay, now there's a question that is, can proxy and wrapper be used from different companies? So yes, we can use proxy and wrapper from different companies. Okay, but so conceptually it is possible. Conceptually any proxy that is there in the market will do the same job that I was showing. It will let Classic client talk to the UA servers, and wrapper will do the reverse. But when you go for a component from different companies, if it doesn't work out properly, the support that you may get may not be the ideal one. Okay, because I've been working, I mean, as Jishan said, right, I've been working in OPC industry for almost 20 years, and I have seen this problem many times when there are components from third-party vendors. Okay, everybody says to talk to other guy first. Talk to other guys, find out what is wrong with them, and it becomes the TT ball tournament where nobody takes a responsibility. So, if you ask me, and you have a choices, why not go from same vendor? If you have verified the vendor, both the products will be good only, isn't it? Okay. Um, so another question is, let me, 1 minute, I'm getting the question. Okay. The question is, can it use different ports? Yeah, obviously. I mean, yeah. So when we're using the proxy and wrapper, we were using some specific port, right? I mean, there'll be endpoint given to them, and that endpoint will be used, and that endpoint, that port has to be configured in the firewall. But there are many places it happens quite many times that you may have two tunneler getting installed in a network, okay, and they may by default start when you start it, they may actually start using the same port, and at the firewall level there might be an issue. So you can say you can actually configure to let them use different endpoints, okay, and you can change the port. It's configurable in the UI part.
Let's take the last question and wrap it up.
Okay, yeah, sure. So can they be used separately? That's the last question. Yes, that I explained it, right? They all are proxy and wrapper are two different products, okay, and they can be used separately based on the business need. It's just that when you put them together, they do the job of a OPC UA tunneler. Okay. Yeah, so I'm done with my question. Over to you, Jishan.
Thank you so much, Mr. Praveen, and it was wonderful session there, and a lot of questions coming in. So if we have unanswered some of them, we will just take it up and we'll answer the remaining ones via email. So if you guys have any further questions, please email us at contact@utthunga.com. We'll be happy to answer them. Before we move on, let's have a poll question for 30 seconds. Request all the attendees to please select your options. Thank you for your answers. Next slide.
Sure. 1 minute.
We have come to the end of our session. Thank you everyone for your participation in this webinar. We hope you have learned how to configure your OPC proxy, wrapper, and tunneler can be used to improvise your OPC communication. Utthunga as a product engineering company can help you build products and solutions from concept all the way through the lifecycle of the product. If you have any other queries regarding tunneler, please feel free to reach out to us at contact@utthunga.com. I repeat, contact@utthunga.com. Finally, do subscribe to our YouTube channel. You can watch our previously conducted webinars. Just search for Utthunga in the YouTube search bar, and you can find the previous webinars there. Follow us on LinkedIn, where we share all our ongoing and latest activities there. Thank you so much for everyone. Thank you. Stay safe.
Bye, guys. Have a good day.